Hello and welcome to Representation and Character Code, your first homework. So in this lesson, we're going to go through the success criteria that you've seen in your booklets. So what you should be doing before the lesson on this video is you should be ticking out the before part to say what you understand and what you do not understand. So you should be selecting either bronze, silver or gold. So if you haven't done that, pause this video now. If you have, let's continue. So, note from Cambridge. So what I want to make clear to you, you are not expected to memorize any particular character code, but you must be familiar with the ASCII and Unicode table, okay? So you must recognize seeing it. So what you will see in the exam is you will see an example given to you of the ASCII and Unicode table, and then you will be expected to calculate the numbers from hexadecimal to denary and so on. Okay, and then obviously you'll be expected to convert numbers because it will all tie in with binary, denary, BCD and 2's complement. So it will all tie in together. So it's very, very important that you know the foundations of Unit 1, because if you don't know the foundations of Unit 1, it's going to be very, very difficult for you to pass the exam. So as you know, when you see one question, that one question could be worth 10, 12 marks. So before we continue, so make sure you subscribe to my channel. You can visit my shop on Test Teachers where you can buy this booklet, and also you can follow me on Twitter. So, what is ASCII code? Now, ASCII code stands for American Standard Code. Now, we know that computers read zeros and ones. We already know that from the beginning of year 12, and if you studied GCSE computer science, then you'll know that from GCSE computer science. But these ones and zeros have various representations for very, very different reasons, okay? So we already know that we can convert denary to binary and to hexadecimal numbers. So what about ASCII and Unicode? So as you know, these various ones and zeros can be represented in various different ways. So, but what about these characters that we see on our keyboard that mean something to us? How do we convert them into something that the computer understands so the computer can compute for us? So each of these numbers are represented, and each of these letters are represented as numbers. So every key you see on that keyboard has some kind of numerical representation. Then the calculations are basically completed by the computer. So every single letter and symbol you see on your keyboard is assigned a number. Okay, A, uppercase A, is assigned 65, but lowercase a is assigned a different number. So every letter and every symbol has a corresponding code for both upper and lower cases. Now, so if we get ASCII to binary, so ASCII can simply be converted to binary very, very easily. So ASCII basically has 7 minimum and 127 maximum different numbers. So we can represent all of the uppercase and lowercase symbols and digits. And we can also have commands such as backspace is represented by 8 and escape is 27. So these are the keys that we see every day, and to us they're just backspace and they're just escape. Okay, escape you might not use that often, but backspace we know we delete stuff. But there are some disadvantages of ASCII, of course. So we're limited only to 127 characters. Now in some languages, it cannot be represented by ASCII because there's far too many characters. So for example, even the Spanish alphabet has one more character in it than the English alphabet does. So for example, if we've got the Greek alphabet, the Armenian and the Hebrew alphabet, and the Arabic cannot be represented by ASCII. But Unicode come along, and Unicode is the same as ASCII, but it uses more bits. So as we know, ASCII uses 127 bits, well, from 0 to 127, so really I suppose it's 128 bits. And it can include all of the alphabets, okay, because Unicode can be extended. So if we take a look at these alphabets here, these can all be represented in Unicode, but ASCII can't represent them because there's not enough bits. So Unicode allows a wide range of symbols, including the ever-growing use of emojis. So there's more and more emojis around now. So if we look at ASCII and how it versus Unicode, now let's not forget that ASCII started somewhere, okay? If it wasn't for ASCII, Unicode wouldn't be around. So ASCII and Unicode do live together hand in hand, okay? So ASCII is our 7-bit code, where Unicode can go from 0 to 127, the same as ASCII. But the extended ASCII only goes as far as 8-bit. And only 128, or maybe, you know, with the 8-bit, 256 characters can be represented. But if we take a look at Unicode, Unicode can be 8 bits, 16 bits, or 32 bits. Okay, so Unicode basically is extended out above ASCII. So, and then Unicode basically was designated to be a superset of ASCII. So it was, you know, made to go further than ASCII to represent more. So it's designed that most of the characters can be represented and include other languages. Okay, so, you know, other languages, emojis, and so on. So with ASCII, 32 bits has allowed well over 2 million characters. Okay, so that's lots and lots of languages that can be represented, lots of emojis, and so on. So our ever-growing use of technology has allowed us to basically move forward. So if we think about converting these character codes, okay, so as I said to you earlier, we've basically got to convert, you know, these character codes into binary or denary. So, right, I'm going to share a whiteboard with you now. So I've got a graphics tablet here, but bear with me, it's not very good. Okay, so, right. Now, so if we take a look, for example, at the letter T, okay, so the letter T in, so if I just, share with you again. So if we take a look, this is one of your exam questions, by the way, that are in the booklet. So if we take a look at letter T, it's 116. Okay, so sharing a whiteboard with you again. So small case T. So the small case T over here is 116 in ASCII, okay? So now, you could be given, for example, you might have to convert that into binary. Well, we know how to convert into binary, so don't be frightened of that, okay? So you get 1 here. Like I said, sorry, bear with me with my awful graphics tablet. 8, 16, 32, okay, 64, running out of room a little bit here, so I'm just going to get the eraser. So we know it's 116 anyway. Sorry, there we go, 64 and 128. Okay, so remember, T, 116. Okay, so we already know what to do there, right? So we know, for example, we've got to make 116, so we know 128 is too big, okay? But 64 will go in, so 64 add 32 is 96. Okay, and then if we add 16 there, 96 add 16 is going to be, probably too much. So what do we do? Think about it. So how are we going to do this? So now, yep, that's right. So it's 112. Okay. So we know that works, but 8 is too much. So now we need to add 4. So that works. So we know that that t value in binary, okay, is 1, 1, 1, 0, 1, 0, 0. Because remember, we'll go from right to left. What about if we want t 116 into hexadecimal? Okay, now if you remember, hexadecimal is a base 16 number. Okay, so it's base 16. So that means we've got to multiply by 16. So how many times does 16 go into 116? Okay, so basically, if you was to calculate this just using your head, then you would know, okay, that would be 70 times, okay? But there's a remainder, okay? So what is the remainder? Now the remainder is 4, okay? So basically, 100, so t in ASCII is 116. In binary, which is a base 2 number, okay, it's this. And in hexadecimal, okay, it will be 74. Okay, so it's just about doing the calculations. So let's not forget that. Now, what about if you get another question? So for example, now as you know, in the exam, you're not allowed a calculator. Okay, so I'm just going to get a hexadecimal number, basically, just literally off the top of my head, okay? So they may say to you, and they will obviously, like I said, give you some sort of ASCII table, but they may not give you a full ASCII table. You might have to sit there and figure some things out for yourself, okay? So they might say to you, for example, here's a number, I'm going to go with this one. Here's a hexadecimal number, okay? Now you've got to convert that into ASCII, and then you've basically got to find out what the letter is in ASCII, okay? So now this is how you do it, right? And it's very, very straightforward. So I said 7A, right? So what you've got to do is break this down into 4 bits. So we know A is 10, because as you know, with the hexadecimal numbers, everything is 1 to 9 until you get to the letters. Now we break this down into 4 bits, okay? So 1, 2, 4, 8, okay, to make 10. Then that has become 0, 1, 0, 1, there we go. Now we've got to make 7. We already know that 8 is going to be 0. Okay, so we know that's going to be 4 there. Then we've got the 2, so we've got the 1. We've got the 1 here, and this is it. Okay, so it's going to be 1, 1, 1, 0. Okay, right, so we know that is 1, that is 2, 4, 8, and you just keep doubling. It doesn't matter how many bits you got, whether you got 12 bits or 16 bits, you keep doubling. Okay, 16, 32, 64. Right, so what I'm going to do now is, hopefully I haven't messed this up. Okay, right, so 64, add 32, add 16, add 8, add 4, add 2, add 1. Okay, here we go. So 4, 6, 10, 18, 22, 24, 23. Okay, so 6, 9, 10, 11, 12, So 1, 2, 3. Okay. So that's 1, 2, 3. So that's 1, 2, 3 in denary. What is that in ASCII? Okay, so I'm going to do a new share now. We're going to look at the table. So in ASCII, 1, 2, 3 is it's a brace. Okay, so in ASCII, and like I said, I just did that completely off the cuff. I didn't even plan that at all. Okay, so in ASCII, 1, 2, 3 is the curly brackets, the brace. Okay, so that's how you do your conversions. Right. So I'm going to go back to the PowerPoint now. Right. Okay. So we've got an exam question example here. Okay. So it gives 2 disadvantages of using ASCII code. Okay. So hopefully you've worked out, I don't know if I can, I can write over the top of this, can't I? So I'm just going to put my annotations on. Okay. So drawing. There we go. Right. So 2 disadvantages of using ASCII code. Okay. Well, it cannot be, sorry, and I'm so sorry about my handwriting on this, represented in, let's say, several languages. Okay, and also it's limited representation, so there's only 128 characters can be represented. Okay, so we can look at those, and then describe how Unicode has overcome the disadvantages of ASCII. Now hopefully you're kind of writing these down or shouting these at the board, but for a start, it's been designed as a superset of ASCII. Okay, plus as well, it can be represented in 16, 32-bit, okay, etc., etc. Obviously, you don't write etc., etc. in the exam. So there can be over 2 million characters can be represented. Okay, right, so I'm not going to write this down because, like I said, writing on this graphics tablet is really hard. Okay, so let's just erase that now, so then we can take a look at the answers. So hopefully you've given that a go. So if you want to give that a go now, properly, okay, because I've just thrown some ideas out there for you, pause this video now, okay, and using a notepad and pen, try to answer those exam questions. Right, welcome back. Okay, so we're going to move on. We're going to take a look at the answers. Hopefully you got them right, and hopefully you gained 4 marks in practice there. Okay, so only 128 or 256 characters can be represented. It uses only values 0 to 127 or 255 if extended to 1 byte. Many characters used in other languages cannot be represented. We went through that. And in extended ASCII, the characters from 128 to 255 may be coded differently in different style systems. In different systems. Now, the next question, which was the ASCII. So the ASCII, as I said, uses 16, 24, or 32 bits. Okay. Unicode is designed to be a subset of ASCII, and then it's designed so that most characters in other languages can be represented. Okay, I hope you found that useful. Now, as you've got the booklet in front of you, I'd like you to give the tasks a go that are in the booklet. And also, I'd like you to give the exam questions a go and self-assess your answers using the answer booklet that's provided. And then, at the end of the lesson, go back, once you've completed all that, go back to the success criteria at the start. And I'd like you to tick on the after section whether you are bronze, silver, or gold. Thank you very much.